This time through, I wanted to discuss some of the linguistic troubles that we have in describing these rather complicated objects we're dealing with. Some of you probably think, some of you probably say to yourselves and others, Cherney makes things harder than they need to be by using these very long, complicated sentences. See, I understand that criticism, but on the other side, what I'm trying to do here is produce very literate students that can spell plain, and so they've seen me make that mistake many times. Okay, it's hard work getting everything right. Okay, but let's talk about the common way that people are sparing in words at the risk of miscommunicating. So here, the plane tangent to x squared plus y squared minus z squared is equal to 18 at 3, 5, negative 4. Is there a tangent to an equation? I mean, so let's see. Here's a point on the equation right there, and then there's a tangent line to it. That's a joke. Right, so this right here is an equation. A tangent line to an equation, I guess, would be a line on the page that touches the equation at just one point. No. We're not talking about a tangent line to an equation. We are talking about a plane tangent to the solution set. To this equation. And 3, 5, negative 4 is one of the points in the solution set to that algebraic equation. See, 3 squared plus 5 squared, let's see, that's 9 plus 25 is 34 minus 16, and that's 18, I hope. Okay, so I add that little thing in there to the solution set to make it clear that I am referring to the solution set of the equation, though I bet you most of you would have interpreted it the same way before I wrote to the solution set 2. Okay, is. Now, once again, I'm saying is and then writing an equation. Right? So the tangent plane, this thing, and that equation was thought of as a solution set until I put that in, and then there was no possibility for misunderstanding. Once again, what I'm referring to here is the solution set to an equation. Think about it. This equation right here is the normal vector to the level set of a function x squared plus y squared minus z squared corresponding to 18. So I am really completely rewording things relative to problem number 1, just to get you thinking about the different way to word things. But I left some space here because I really do want to add in here is the solution set. This is an algebraic equation in 3 variables x, y, and z. It's equivalent to this equation, which is equivalent to this equation, which is equivalent to this equation, which is in perhaps the most familiar form out of all of these, and it looks very much like the equation that you usually see for a plane. 6x plus 10y plus 8z, and if I moved all of the constants over to the other side, that would probably be the form that you're most accustomed to seeing. Okay. So this is perfectly good. However, in problem number 1, I really do think that I gave a better wording, because notice I never actually talked about a function anywhere in number 2 right here. And if you want to explain to someone why it is that the gradient is appearing, you want to say, I am taking the gradient of this function for a certain reason. Now, in number 1, I start out by saying, since the gradient of a function is normal to the level sets of that function. Here, the rationale is not spelled out as well. Okay. And before we go, I'll apologize for that mistake right there. It's almost as bad as misspelling plane. I won't stop recording.